So the key terms in chapter 5.1 are cycle, period, periodic function, and amplitude. So what is a cycle? A cycle is one complete repetition of a pattern. A period is the horizontal length of one cycle on a graph. The periodic function is a function that has a pattern of y values that repeats at regular intervals. And the amplitude is half the distance between the maximum and minimum values of a periodic function. There's only one important key concept in this section, and that is to know what a periodic function is and how it looks like. So you can differentiate this function from a different function because it has repetitive y values. This is what makes it a periodic function. As you can tell, after 5 units, or every 5 units, the y value is constant. It's -1 at the bottom. At the top, it is +4. Now, this periodic function has 3 cycles, or 3 complete repetitions of a pattern. And one period, or the horizontal length of one cycle, is 5 units. The next part that I want you to know is that how to calculate the amplitude of any periodic function. The formula is the maximum value minus the minimum value all over 2. So in this function, the maximum value is 4 minus the minimum value, which is -1 all over 2. This will give you 5 over 2, or 2.5. The one example in this section is to use the graph on the right and answer the following questions. So number 1, what is the period? Now, we know what a period is, and since this point is at -5 and this is at 1, we can conclude that the period is 6 units. B, determine what F2 and F5. F2 is 1 because if you look at 2 on the y-axis, you can tell it's 1, and F5 is on the x-axis. Predict F8 and F14. To do this, you must completely understand the pattern of this periodic function. Now, F8 is equal to F2 plus 6, which is equal to F2, which equals 1. Now, F14 is equal to F14 minus 6 minus 6, which is equal to F2 and then equal to 1. The last thing is the amplitude of this function. We know how to calculate the amplitude, so the answer is 3 minus -2 over 2, which equals to 5 over 2. There's only one main key term in section 5.2, and that is sinusoidal. This means having the curved form of a sine wave. In section 5.2, the graphs are the most important thing. Here you have 2 graphs, the sine and the cosine function. To your left you have the sine function, which intersects the x-axis at 0, 180, and 360 degrees. Below this, you have all the characteristics of the sine function. To your right, you have the cosine function, which intersects the x-axis at 90 and 270 degrees, which is the exact opposite of the sine function. Below the graph, you have the characteristics that describe the cosine function. There's one important example in chapter 5.2. So the question is, you were in a car of a Ferris wheel. This wheel has a radius of 8 meters and turns counterclockwise. Let the origin be at the center of the circle. So, sketch the graph of your horizontal displacement versus the angle through which you turn. Which function does it model? And do the same with vertical displacement. So here you have the graph of the horizontal displacement. It starts at 8, dips down to -8, and goes back up. Now, as we looked at before, this has a similar shape as a cosine function. So, it models the cosine. Now, when you look at the vertical displacement, it starts at 0, goes up to 8, comes back down to -8, and reaches 0 again. Now, this looks exactly like the sine function. So, it models the sine.